I'm Karen Burton, and this is the overview of the Clemson University Arthropod collection and metadata recommendations for this collection. I chose this collection because I have an entomology degree from Clemson myself, and I spent a lot of time looking at specimens in this collection. It is located on the top floor of a biology building in Clemson University in Clemson, South Carolina. It contains approximately 1 million alcohol-preserved specimens, which are in a tiny vial, and they're in drawers, as you can see in the top right picture with the big flammable labels. It also contains about 200,000 pinned specimens, which are insects on a pin, that are housed in boxes and drawers in the cabinets, like you see on the bottom right. It's used for teaching and research in a variety of ways. Students can come and they can look at the specimens, they can compare them to what they have and do identifications. And people can also use the metadata to answer all kinds of research questions. The users are mainly the Clemson faculty, staff, and students. Outside users include other universities, pest control companies, or sometimes government agencies like the Forest Service. The director and collection manager are two unique users that we'll talk more about later. The item to be described is a specimen. On the left, you see an example of a pinned specimen, and those pieces of paper include various types of metadata. Usually there's one label that has the collection metadata, like who collected it, when, and where, that stays with the specimen throughout its lifetime. And then the second label below that is usually the determination data, in other words, the identification. Same thing for the alcohol-preserved specimen. It's just in a vial of alcohol instead of on a pen. We already talked about the users of the Clemson University Arthropod collection, and most of these users are going to be searching for phylogenetic relationships, in other words, how different organisms are related and what you find in the arthropod collection. For example, they may want to know all the different species of cockroaches that have been found in South Carolina, and we know that's a lot. People also search for geographic data, what specimens were found where, and what specimens were found when, so they search for temporal data. And they may also want to search for people, such as who identified specimens or who collected them. The collection director and collection manager need to be able to handle loaning specimens to other institutions. They need to know who has what, how they shipped it, if it got lost while it was shipped, either to the other institution or back to Clemson, and what condition the specimens were returned in. So they have some very unique user needs. The physical organization and the digital organization of the Clemson University Arthropod collection are going to be totally different. The physical organization is arranged by taxonomy. So in other words, similar insects are grouped together in drawers. And within that taxonomy, it's alphabetically. For example, you might have all the butterflies in the swallowtail family in one drawer, and then the genus would be alphabetically arranged in that drawer. The digital organization system has a catalog number. Each specimen has a unique catalog number. There's two types of metadata that need to be added to this collection. Prospective databasing is when, for example, you go on a collecting trip, you get 100 specimens, they all have the same collection metadata, who, what, when, and where, and that needs the ability to be added in a batch and not have to do each individual specimen. Retrospective databasing is, going with my same example, 10 years later you find those 100 specimens again, and you want to identify each one, and that's individual, so that's retrospective databasing. The metadata scheme I've chosen for the Clemson University Arthropod collection is Darwin Core. It is the standard scheme for biological specimen collections of all types, from insects to marine biology to geology. Everything uses Darwin Core in biological sciences. Darwin Core was put together by the Biodiversity Information Standards Taxonomic Databases Working Group, and that's a mouthful. Basically, they decided that collection data shouldn't stay local to just your individual collection, because aggregating that data is extremely helpful. So Darwin Core was created to enable open sharing through exporting your data as Darwin Core archives to data aggregators. The encoding scheme I recommend for the Clemson University Arthropod collection is Ecological Markup language, which is an XML markup syntax and is also a standard in Earth Environmental Sciences like Darwin Core. The content standards can be found at this address. They're maintained and updated by the Darwin Core Maintenance Group of the Taxonomic Databases Working Group. I won't go through all of them here, but we'll see some in my item record later. There are actually few controlled vocabularies specified in the content standards. There is not one singular source for scientific names, but one good one is the Integrated Taxonomic Information System because it also easily integrates with some data aggregators we'll talk about later. You also need to cite the identification source, in other words, the book you're using to identify your specimen, in your metadata. Location has controlled vocabulary, what language, the time has a format, and the date has a format. There are two main data aggregators for biological specimen collections. Global Biodiversity Information Facility, or GBIF, is an open access data aggregator for species occurrence datasets from around the world. By species occurrence datasets, they mean collections of biological specimens because those tell you when and where they occurred through their metadata. Integrated Digitized Biocollections aggregates data and images from millions of biological specimens. They focus more on the images, but they also provide a link back to the GBIF actual data set. So they both have extensive mapping and searching functions. You can search with different facets, as you'll see later, and you can also download your data after you've found what you wanted and sorted it how you like. The Clemson University Arthropod collection has two options for their content management system that I would recommend. The first is through Symbiota, which is an open source content management system for curating specimen and observation-based biodiversity data. It's basically a database for individual collections to upload metadata about their specimens to. It has modules for different areas like marine biology or geology. Ours is the Symbiota Collection of Arthropod Networks, or SCAN, and it aggregates and exports the data through Darwin Core archives. It's currently free and grant-funded, but as we all know, grant-funded means that's subject to change. The other option, Arctos, is a consortium of museums and organizations that collaborate to serve data on over 3 million records from natural and cultural history collections. They also aggregate and export data through Darwin Core archives, but it does cost. They charge you per specimen record. And the more specimen records you upload, the cheaper it is per record. So that's another option. They have very reliable backup through Texas Advanced Computing Center, but it does cost. This is a screenshot of the homepage of SCAN. Clemson University uploaded some of their data a while ago, but not all of their collection data. So you can see what the page looks like. And there's a link to the GBIF dataset page because SCAN aggregates all their data into GBIF. This is a screenshot of two different parts of the Arctos system. The first line that says Chicago Academy of Sciences is how you look at one specific collection. You can see details about it or you can search within that collection. And the rest of the screenshot is the search interface for Arctos, which has a lot of different facets you can search under. This is a screenshot of the search interface for GBIF. I have it limited to the Clemson University Arthropod collection. Currently it's showing occurrences or pins in the map for swallowtail butterflies that are in the collection. As you can see on the right, there are many different facets you can search in. This is an example of the basically browsing function of GBIF. If you want to know what kinds of butterflies they have, you can look through all the different families here in the middle column, and you can see a pretty picture of the taxonomic distribution on the right side. And if you go down on the screen, it will tell you where all the occurrences are, and you can group them by family or class or whatever you want to. There's a lot of different ways to rearrange your data however you want to see it. And you can also download it using a different screen. This is a screenshot from the search interface for iDigBio. I am currently searching for the praying mantis, Mantis religioso. and is also showing me the pins on a map, just like GBIF did. If I look further down on the screen, I can see different tabs. So I can look under mapping, I can draw pictures and see what's inside that. I can sort them by genus or species or collection date, and I can also download it as a comma separated value file. And at the bottom of the screen, it gives me a list of all the specimens of Mantis religioso that I'm finding, and it tells me when they were collected and the institution code, so I know where it came from, and I can click on View to get more data about that specimen. It also shows me, under the Labels tab, essentially those collection labels I talked about at the beginning. So that's a really neat feature. The Media tab shows you a picture, because iDigBio has a lot more in the way of image data. And then the last tab, which was the record sets, is down here at the bottom and is the collection that the specimen whose record I pulled up is contained in. This is an item record for the Clemson University Arthropod collection. This is an actual item record from their metadata. I simply removed the fields that don't have a value for them. So you can see the list of Darwin Core terms on the left and the values on the right. The item records continued on the right side of the screen because the picture wouldn't fit in one column so you could actually read it. So the catalog number is the individual identifier for that particular specimen. The preparation will always be alcohol or pinned. The institution code and collection code are pretty self-explanatory. The basis of record is always going to be preserved specimen for this collection because it's not an observation or anything like that. The kingdom, phylum, class, order, family, scientific name, genus, and specific epithet all have to do with the taxonomy of the specimen. The scientific name authorship refers to the person who first described the species and the year, and it's always going to be in this format you see here of last name, comma, year in parentheses. Identified by is the name of the person who performed the identification on the specimen, and the date identified is when they did it. The event date is also when it was collected. You can see the year, month, day are pretty self-explanatory. The verbatim event date is exactly how it's written on the label that is either in the alcohol vial or on the pin with that specimen. The habitat is where you found the specimen, in this case in a marsh, or it could be in a tree in a field. That's a free text field. Individual count means that there's only one specimen. This is usually a thing with alcohol vials because you can have multiple specimens per vial sometimes. The country is also a free text field, but country code is controlled vocabulary, as is the state or province and the county. Location remarks or anything else you want to say about where it's collected. And the latitude and longitude are so you can actually find the GPS coordinates for it. Modified is when the last time that this record was modified, and the license in this case is Creative Commons 0 because this is data and it's not copyrightable. So in conclusion, for the Clemson University Arthropod collection, I recommend the Darwin Core metadata scheme with EML encoding because it integrates with GBIF and iDigBio, which are the two big biological specimen collection and species occurrence dataset aggregators. As for the content management system, SCAN or Arctos, it's a hard question. I would need to know more about the user interface, like the ability to bulk import metadata for prospective databasing. If it already has some system in place to handle loans, can you add local elements? And if so, how do you do that? And of course, budget. Budget is always going to be a factor. Free or paid? Is the free more expensive or is the paid more expensive? That'll depend on your situation. One thing I would recommend is that the director and curator of the Clemson University Arthropod collection talk to their counterparts at universities or other collections that use both systems, because real-world experience is always better than those fancy marketing brochures you find or what you read on their website. I would want to know the real-world experience for both of these content management systems before making a decision. Thank you for listening, and I hope you enjoyed learning about biological specimen collections and how to create good metadata for them. Thank you.